choose the right tool for the job at hand. An electrical drill can also have a set of tips for different types of screws. Clamps. A clamp is a fastening device to hold or secure objects by tightening these together to prevent movement or separation through the application of force or pressure. There are many varieties to meet the needs of different workshop tasks. Most of the adhesives depend on high pressure to form a solid bond, and the parts need to be clamped for long periods. Also, clamping a work item firmly before any operation is a vital part of safe woodworking practice. Types. Sash or bar clamp. A bar clamp is a tool used when working with wood materials in the final assembly of joinery work. The sash clamp is available in sizes from 500 millimeters to 2.135 meters. G-clamp. A G-clamp is the most widely used and versatile clamp in the clamp family. These are generally made of steel or cast iron, with the exception of some smaller clamps which may use hot metal. These clamps come in a wide variety of sizes, in length and in throat depth. Miter clamp, a specialized tool that is ideal for frame making. It puts two components together to meet at the center of the clamp, which guarantees a true right angle. Safe use of clamps. It is good practice to clamp materials to a workbench to avoid movements, which can result in an accident. Section 3. At the end of the section, you should be able to discuss the types of finishes. Wood is porous and is an absorbent material. If left unfinished, it will absorb moisture, oils, and dirt. As a result of general use, after a period of time, unfinished wood discolors, shrinks, swells, or warps. Finishes can help to protect the wood against these conditions and enhance the beauty as well. The application of finishes is the last stage that gives the furniture its new look. Before this is done, the furniture has to be prepared to receive the finishing materials. To do a good job of wood finishing, you must know the properties of the wood, the characteristics of the finish, and the correct and safe methods of application. All wood finishes can be grouped into three general types. Transparent coatings are coatings that can be seen through. Examples include shellac, varnish, and lacquer. Penetrating finishes actually soak into the wood rather than just coat it. These may be applied plain or mixed with color. Examples include linseed oil, Danish oil, and tung oil. Opaque finishes cover the surface completely. These cannot be seen through. Examples include paint and enamel. Let us consider some of the materials for finishes. Polyurethane. Polyurethane is the finish most resistant to moisture, heat, chemicals, and abrasions. However, its application has a cloudy appearance. Oil finishes. There are many different kinds of oil finishes. Some are easy to use and others are very time-consuming. Linseed oil, boiled. Linseed oil was the choice of the old-timers. Linseed oil gives a fantastic finish, but you need a very long time to apply it. This may add up to several weeks. Other oils. The other oils are much easier to use. Danish oil and tung oil are two popular oil finishes. They are very easy to use and come in clear and pigmented colors. Varnish. Varnish is linseed oil mixed with the shellac flakes instead of alcohol. It requires a sanding process between each application coat. Lacquer. Lacquer is a very durable finish. It's flexible and is very easy to keep up. Lacquer is easy to apply, rub, polish, repair, and if necessary, strip and remove. Regular lacquer should only be applied with spray equipment, but with proper mix of thinner, it may be rubbed. Steps in applying finishes. Although the materials may vary, all finishing is done in about the same approach. There are several basic steps. We will discuss the following steps. 1. Sanding. It is important to sand the wood before applying any finish. Sandpaper is graded depending on the number of sand granules per square inch of paper. The greater the number, the finer the grade of paper. Smaller grade number, the coarser the sandpaper. This number is usually printed behind the paper. Medium grade paper is used to remove the existing finish from furniture and antiques. Fine graded paper is for the last sanding of furniture just before staining the wood. Sand with progressively finer grade papers, starting with medium to fine. Sand in the direction of the grain, never against it. Sanding against the grain will cause scratches that will show up on finished wood, especially after staining. 3. Staining. Staining is done to enhance the grain and to achieve the color you want. Before staining the wood, dust must be taken off the surface. 4. Sealing. Sealing is done to seal the stain and thus prevent it from bleeding into the top coat. It enriches the stain and stiffens the fibers of the wood. 5. Filling. Fillers are needed to close the pores of open-grained, porous, and semi-porous wood. 6. Applying the top coat. The top coat may be shellac, varnish, lacquer, penetrating oil, paint, or enamel, or others. Usually 2 or more coats are needed, and surface is sanded between each coat. 7. Rubbing, buffing, and waxing. After a clear top coat, such as varnish or linseed oil, is dry, the surface may be rubbed, polished, and waxed to produce the desired sheen and to provide additional protective coating. Applying finishes safely. Safety precautions. Keep safety uppermost in your mind when working with finishing material. All finishing materials have some degree of danger associated with them. Be sure to observe the following precautions. 1. Wear approved eye protection. 2. Cover your clothing with an overall. 3. Wear a respirator when you are spraying finishing materials. 4. Avoid breathing fumes from toxic materials. And 5. Wash your hands thoroughly after using any finishing material. Section 4. Practical applications. Use of glue. A very important component of fixing pieces of wood together is using glue. Wood glue is an almost indispensable material in a wood workshop. Glues were once made from natural materials such as animal parts. They were boiled to produce a brownish-colored jelly which slowly solidified. This was called Scotch glue, and it could be warmed up later and used as liquid glue. Presently, PVA, polyvinyl acetate glues, are the preferred choice as these can be used straight away. These are usually supplied in a plastic container. The drying time of these glues is stated on the container. The marking and cutting of joints have been covered in the videos on marking and cutting tools. Here we will put together these joints. Butt joint. Glue, nails, or screws are used to fix butt joints. In this case, we are going to use glue and nails. 1. Apply glue to the areas to be joined on both pieces of timber. 2. Clamp the pieces together. And 3. Use a bradawl to pre-bore the holes for the nails. This will prevent splitting of the wood since we will be nailing close to the edge. 4. Using a hammer, drive the nail at a slight angle from vertical to make the joint strong. Edge joint. An edge joint is a form of butt joint. It is joining the edge of a narrow piece of board to form large panels such as tabletops. The edges should be perfectly straight and perpendicular with the face. This can be achieved by using the joiner plane or hand plane. 1. Arrange the boards together in the position that they will be joined. 2. Mark them so that they can be placed in the same position when the glue is applied. 3. Apply glue to the edges and use 3 clamps, 1 at each end and 1 in the middle on top. 4. Make sure the boards are seated on the clamp and use a straight edge to test the upper surface. Miter joint. 1. Apply wood glue. 2. Dado joint. Apply glue to both pieces of wood on the areas that will be put together. Clamp until the glue is set. Halving joint. We will use screws to fix the halving joint. 1. Apply wood glue to both pieces of wood and assemble the joint. Use a drill to bore pilot holes at these points. This will help prevent the wood from splitting. Use a screwdriver to drive in the screws. Lock shoulder joint. Apply glue to both pieces of wood on the areas that will be put together. Clamp until glue sets. Dovetail joint. To fix the dovetail joint, apply glue to areas that will be joined together and clamp. In some situation, a screw or nail can be used to hold together the joint until the glue holds. We will assemble a table consisting of mainly mortise joints. 1. Assemble the 2 frames of the narrow side of the table first. Each frame consists of 2 legs and 2 rails or shorter rails. 2. Apply glue to the tenons and the mortises, and using 2 sash clamps, clamp the frame together. Clean up any excess glue that is squeezed out of the joint. 3. Make sure the frame is square by checking that the diagonal are equal or use a tri-square to check it. 4. Repeat the process with the other 2 legs and with the 2 shorter rails. When the glue is set, remove the frames from the clamp. Apply glue to the remaining mortise and tendons. Clean up excess glue with a wet rag. 5. Sand from coarse to fine of the 625mm or 100mm table parts using hand sanding. 6. Fill, stain, seal, and apply lacquer using a spray gun to the table parts. 7. Assemble the table frame. Quiz. 1. State 2 types of hammers. 2. State the application of each of G and miter clamps. 3. What are some of the safety factors to consider when using finishing tools? 4. What determines a type of finish to be used? List 3 personal protective equipment used when applying finishes. Planer. Introduction. The equipment used in woodwork has evolved from simple hand tools to stationary power machines which are more accurate, require less effort, and work faster. Among these machines are surface planer or jointer, panel or thickness planer. This video will look at the main parts of these machines, main uses, and how to use these machines safely. Surface planer, jointer. The primary function of a jointer is to produce a flat surface along the length of a board. Infeed table. The infeed table is the front table of the jointer over which the stock is first passed. The depth of the cut to be made is controlled by adjusting the height of the infeed table using the adjustment knob or handle located just below the infeed table. Outfeed table. The outfeed table receives the wood after it passes over the cutters. For regular jointer work, the outfeed table should be set on the same height as the cutter knives. The height of the outfeed table may be adjusted by the adjustment knob on handle located just below it. Cutter head. The cutter head contains 2 or more cutting knives which are honed to a very sharp edge. The knives are arranged in the cylindrical cutter head such that their cutting edges protrude from the cutter head so that they will come into contact with the board being cut as the cutter head spins. Bridge guard. The guard resides over the cutter knives and moves by a spring action to allow the stock to pass through when fed from the infeed table. The guards ensure that the cutter is always covered, limiting the possibility of a woodworker sustaining an injury from the jointer. Fence. The fence is used as a guide for planing, as the true edge or surface is usually held against it when planing. The fence of the jointer may be adjusted across the tables or at an angle to the table. Pressure springs. These are used to keep the wood in contact with the table when planing long lengths or cutting bevels. Before operating the jointer, it is important to ensure the fence is perpendicular to the table. Use the tri-square to check if the fence is perpendicular to the tables. If not, make the necessary adjustments. Check to ensure that the outfeed table is on the same height as the cutter knives. If not, make the necessary adjustments. Surfacing. This is the process of producing a smooth, flat and straight face side on a piece of timber. The procedures for surfacing on the jointer are as follows. Examine the surface of the board to ensure that it is free from impediments such as nails or screws. Cut the board to the projected width and length. This will minimize the amount of planing required. Feed wood into the jointer from the infeed table to the outfeed table. It is important to ensure that the surface of the wood remains flat on the outfeed table and the true edge remains against the fence. It is much easier to joint a surface when the bow is facing upward in the center of the board. Attempting to joint a piece of stock when it is rocking on the table is extremely difficult. Do not apply too much downward pressure on the wood, as this will flatten out a bow in the wood. But when it passes the knives, it will revert to its original shape. When enough wood is on the outfeed table, place both hands on the table and finish the cut. If the wood has a defect such as an arc or bow, apply enough pressure to keep the board level as possible to the cutter head during the initial cut. As soon as the jointer makes a flat surface, concentrate on that spot on the outfeed table. Another way to plane distorted boards is to swap ends between the initial cuts, then plane with the grain to smooth the board. Squaring up a second edge. Usually, after surfacing a face, the next step will be to square one edge perpendicular to the face that was just surfaced. First, verify that the fence is square to the infeed and outfeed tables using a tri-square. Squaring an edge is similar to surfacing. The difference is that consistent pressure will be applied primarily to the fence. Place the previously planed face against the fence and move the stock over the cutter, keeping your hands safely away from the blades. Make several passes until the edge against the cutter is perfectly flat and square to the edge against the fence. You will now have two adjacent surfaces that are flat and perpendicular to each other. The following are some safety rules for using the jointer planer. Before using any jointer, always check to ensure that the guard is in place and fully functional. Always turn off isolator when removing or installing cutter knives. Make small cuts to avoid using extra force to feed stock, as this may cause an accident. Never plane a piece of wood that is shorter than 300 millimeter. Avoid placing hands closer than 150 millimeter to the cutter. Never plane across the grain of the wood. Always use a push block when planing near the cutter. Panel thickness planer. A thickness planer is a tool used for smoothing rough lumber or reducing the thickness of a board. With a thickness planer, every board on a project can be of constant thickness, hence a perfect match. A thickness planer will not straighten a distorted or twisted board. This is why it is necessary to straighten the board first with the jointer. The usual procedure is to joint the face and edge of a board. Run it through a thickness planer to get the correct thickness, and then rip it to width on a table saw. Table. The table of the thickness planer is adjustable up and down and has a graduated scale fixed to the side to indicate the thickness outcome of the timber after planing. The rise and fall wheel. This is a hand wheel located at the top front section of the thickness planer. It is used to adjust the height of the table, thus controlling the thickness to which the timber will be planed. Gear change lever. This controls the speed at which the timber is fed through the machine. In-feed and out-feed roller. The in-feed roller pulls the wood into the machine and under the cutter head, while the out-feed roller pushes the wood from under the table after planing has taken place. Cutter block guard. This covers the cutter head, adding to the safety of the operator. It is hinged at one side to access the cutter head for maintenance purposes. Cutter head. The cutter head of the thickness planer is similar to the cutter head of the jointer planer, having two or more knives which are honed to a very sharp edge and arranged radially in the cylindrical cutter head such that their cutting edges protrude from the cutter head so that they will come into contact with the board passing below it. Make sure the thickness planer is bolted down or securely fastened in place. Remove any nails or staples from the wood. With the thickness planer's height adjustment, lower the cutting head until it just touches the surface of the board. Remove the board and lower the head another 2 millimeters for the first cut. Send the board through for a first pass. The machine will automatically feed the board to its outfeed table. Follow with several gradually deeper passes. For softwood such as pine, remove only about 2 millimeters from the surface per pass. Remove less per pass for hardwood. Safety procedures. Even though the thickness planer is a simple machine, it can be dangerous if not used safely. Among the safety precautions governing the use of the thickness planer are: always ensure that the cutter block guard is down before use. Never place hands below the table. Never use force to feed material through the plane. Allow the infeed and outfeed roller to do their work. Always be sure to turn off the machine before lifting the cutter block guard or carrying out any form of maintenance procedure. Table saw. Section 1. Introduction to table saw. The table saw is basically an electrical powered machine with its main parts a table, a blade, a motor, and a set of accessories. It is used to cut wood for different applications. The wood is rested on the top of the table and pushed onto the rotating blade. Some of the main uses of the table saw include cross-cutting. Cross-cutting is cutting of timber across the grain of the wood. Ripping. Ripping is cutting of timber along the grain of the wood. Beveling. Beveling is cutting the timber at a given angle. Main parts of the table saw. The following are the main parts of a table saw. Blade and blade guards. Blades can be of different sizes and types. The blades are used for cutting, while the guards covering the blades protect the operator of the saw. Rip fence. It is the fence attached to the table saw. Its position is adjustable, and it can be removed when not required. Blade height adjustment wheel. It is used to raise and lower the saw blade. Blade angle adjustment wheel. It is used to adjust the cutting angle of the saw blade, usually between 45 and 90 degrees. Controls. These are switches which turns the machine on and off. Miter gauge. It is used for cross-cutting and fits to a groove on the table for cross-cutting. The gauge can be locked at a desired angle, usually between 45 and 90 degrees. It can also be removed when not required. Safe use of the table saw. The following are the main safety precautions to be taken when using a table saw. Wear appropriate personal protective clothing and safety gear. Always turn off the saw using on-off switch as well as isolation switch on the wall. When you are changing blades, doing routine tune-ups, cleaning the scraps on the table, or any other changes to the saw. Set the saw blade at no less than 3 mm, but usually not greater than 10 mm above the workpiece. Lock the fence for ripping. Always plug the saw into a grounded electrical outlet. Never operate your saw in wet areas. Make sure the electrical cord is out of the way. Keep your hands away from the blade. Use a push stick. This reduces the chance of a serious accident. Know the table saw danger zone. After cutting, only retrieve the wood after the blade comes to a complete stop. Never cut freehand. Use the rip fence when cutting the wood lengthwise and miter gauge to cross-cut timber. Stand to the side of the cutting path. Do not stand in line with it. Normally, kick back and throw the wood straight back from the saw blade. Sharp saw blades are less likely to kick back. When you turn on the saw, let the saw blade reach full speed before each cut. Keep your saw table free of tools, scrap, and extra wood. Clean the saw blade with a brush and not with your hands. When you see resin buildup, unplug the electrical cord, remove the blade and scrub the blade with a degreaser and a hard bristle brush. Quiz. What are the main types of cuts which can be made using table saw? Ripping, cross-cutting, and bevel cuts. Making cuts. Cross-cutting. As we know, cross-cutting is cutting across the grain of the wood. A. When making a cross-cut, usually one of the first things you would want to do is to remove the rip fence from the machine if the piece of wood is long. B. Adjust the blade to a suitable height of about 6 mm above the piece of wood you are working with. C. Ensure that the miter gauge is properly aligned, that is, in this case, perpendicular to the blade, and tighten it properly. D. Make your mark on the wood and indicate the waste piece. E. Push the miter gauge with the wood to see that the mark on the wood is aligned with the blade. Pull back the miter gauge and start the machine. Hold both the wood and miter gauge together and slowly push to the blade until the cut is made. Slightly pull away the wood from the blade and pull back the miter gauge away from the blade. Repeat the procedure if necessary, otherwise switch off the saw until ready to make a next cut. Making cross-cut using rip fence. Cross-cutting with the rip fence can be very dangerous if not used properly, but can be helpful if the cuts of the same size are done repeatedly. To avoid kickbacks, where the wood being cut flies back at the operator causing serious injuries, always clamp a supporting block on the rip fence. Now we will demonstrate how cutting the timber along this grain is done. This is done with the rip fence in place on the saw table. Adjust the fence to the desired measurement relating to the width of the wood to be cut. Tighten the rip fence. Set the blade about 6 mm above the wood. Allow the well-dressed edge of the board to rest on the rip fence. With the correct standing position and not being in front of the blade, push the timber to the blade. Ensure that the fence is firmly placed and the stock runs parallel to the fence. Ripping large sheets of material. 1. In this case, use a supporting or expansion table to the left side of the machine and a roller stand or a second table to support the length of the material. 2. As usual, you would adjust your rip fence to the desired measurement before turning on the machine. 3. Check the rip fence if it is tightened properly. 4. Feed the material to the saw blade with firmness. Do not try to pull back, twist, or turn the material while being cut, as it will cause kickbacks. Use of push sticks. Push sticks can be purchased, but you can make your own with plyboard to guide the material in the machine for cutting. The push stick will help the operator from being cut or sustaining injuries while using the machine. Setting the table saw. Adjusting the blade angle. Place a square against the saw blade between two teeth of the blade. The blade of the square should align with the saw blade. If there is a gap between the two, rotate the saw blade angle adjustment crank until the saw blade aligns with the square's blade. For the angle of 45 degrees, use a sliding bevel instead of combination square, which is set to 45 degrees to adjust the saw blade angle. Rough adjustments of the angle of the blade could be done using the blade angle scale marked on the table saw structure. Align the miter gauge with the table saw blade. Place a carpenter's square against the miter gauge surface and the flat surface of saw blade between the teeth. The square should align with the gauge. If there is a gap between the two, loosen the adjustment handle on the gauge and adjust the miter head to align it with the square. Tighten the adjustment handle on the gauge. Raising the blade. Raising the blade is changing the blade height from one level to another. If the blade is too high above the wood being cut, it can cause some sort of risk due to higher exposure to the operator. If the blade is too low, it may result in the wood not being cut right through. Use the blade adjustment wheel to raise the blade to your desired height with the assistance of a ruler. Saw blades. Introduction. A dull or chipped table saw blade will not perform in a satisfactory manner. It is very important that the saw blade is sharp. Replace a blade that is dull or cracked, has chipped teeth or damaged, as more accidents are caused by dull or damaged blades than sharp ones. To protect blades from damage, avoid stacking them directly on top of each other. Hang them individually on hooks or place cardboard between them. Parts of a saw blade. The carbide tip. It does the cutting and is kept sharp. Anti-kickback feature. Helps to reduce kickbacks. Copper reinforcement shoulder. A piece of copper to reinforce the tip. Gullet removes the sawdust. Expansion slot. The machine blade will experience a lot of heat when in use, which will cause the blade to expand and crack. To avoid this type of damage, a space is made in the blade, which is called the expansion slot. Types of blades. Main types of blades include rip blade, crosscut blade, anti-kickback blade, and combination blade. Now let us explain these different types of blades. Rip blade. This is designed for cutting along the grain. It has deep gullets and relatively large teeth. Crosscut. This one is designed for cross-cutting and have more teeth than the rip blade. Anti-kickback. It is a variation of the standard cross-cut blade. In this case, the shape of the teeth limits the size of the cuts made with each bite. So less aggressive bites help to reduce the chance of kickbacks. Combination blade. This is a general purpose blade for ripping or cross-cutting. It does not cut as efficiently as the rip blade for ripping or cross-cut blade for cross-cutting, but it makes frequent blade changes unnecessary. Changing the saw blade. Removing the blade. Let us work from the front of the table. We can place a wedge piece of scrap wood under a blade tooth to prevent the blade from turning. Use the wrench supplied with the saw blade to loosen the arbor nut. The nut usually loosens in the direction of the blade teeth, clockwise. Completely loosen the nut and unscrew it with hand and carefully take it out. Remove cautiously the blade and the washer off the arbor. Replacing the blade. Slide the replacing blade on the arbor with its teeth pointing in the direction of blade rotation towards you standing at the front of the machine. Insert the washer and nut and start tightening by hand. When you are unable to further tighten it by hand, use the wrench to do so, but don't over-tighten it. Conclusion. Properly setting up the table saw and observing important safety measures are essential in operating the table saw. Appropriate selection of the blades is important for Section 4. Practical applications. Using a wooden board of dimensions 150 millimeter long, 250 millimeter wide, and 19 millimeter thick, we will demonstrate the application of table saw to produce 4 pieces of wood measuring 525 millimeter by 56 millimeter and another set of 4 pieces measuring 800 millimeter by 56 millimeter. First, we will rip to get the required width. Adjust the blade height to between 6 millimeter to 10 millimeter above the board. Set the fence 56 millimeter from the table saw blade. It is the required width of the wood to be cut. This 56 millimeter is measured from the rip fence to the surface of the blade parallel to the fence. Please keep in mind that during the process of cutting, the blade will take out approximately 3 millimeter of the wood, dependent on the thickness of the blade. Turn on the table saw and place the wood against the rip fence and gently push towards the blade. Keep a steady motion and don't try to push too fast. Let the blade do the work. Concentrate on keeping the board against the fence at all times. As the end of wood approaches the end of table on the table saw, use a push stick to complete cutting the wood. Repeat the process to make a second cut. Then the third cut. Now the fourth cut. And you have 4 pieces of wood. All these pieces are 1,500 millimeter long and 56 millimeter wide. We will now cross-cut the pieces to get the required length. As we are going to cut several pieces of the same length, we will use the following process. Remove the rip fence. Make sure the miter gauge is perpendicular to the saw blade by checking it with a square. Choose a straight piece of board about 1,200 millimeter by 75 millimeter by 19 millimeter. Usually the length of this piece is related to the length of the piece to be cut. This piece will be used as an extension fence parallel to the surface of the miter gauge. Screw this extension fence to the miter gauge with the right end projecting about 50 millimeter past the blade. Now turn on the saw and push the fence through the blade to cut the additional length so to align the right end of the fence with the saw blade. Turn off the saw. Place along the fence the piece of board of 1,500 millimeter by 56 millimeter by 19 millimeter dimensions, which was cut before. Start the saw. Hold the board firmly against the fence and slowly push it through the blade to see the edge is cut as a square. After the cut, slide the board away from the blade and turn off the machine. Remove the piece which was cut. Do the same with the other 3 pieces. Ensure that one end of each of the board is square. Now mark a point 800 millimeter from the square end of one of the boards and mark a cross cut at the mark. Now use the board you have just cut as a reference. To do so, you align this piece along the fence and place a small piece of wood with a clamp to the other end of it to fix the position of the newly cut piece. Other 3 pieces will be cut according to the length of this board. You will now have 4 pieces exactly 800 millimeter long. You will also be left with 4 pieces of about 700 millimeter length each. Use one of the 700 millimeter piece and make a mark at 525 millimeter and cut at the mark to get a piece of 525 millimeter length. You will use this newly cut piece as a new reference to cut the rest of the 3 pieces. Now you have 4 pieces of 525 millimeter length. Quiz. Question 1. What are the common types of saw blades used with table saw? Answer: rip blade, crosscut, anti-kickback, and combination blade. Question 2. Name 4 parts of a table saw blade. Answer: the carbide tip, anti-kickback feature copper, reinforcement shoulder gullet, and expansion slot. In this video, we will be discussing timber technology. Timber is used in construction and furniture industries. We will be demonstrating the various stages in converting a tree into marketable size lumber. Section 1. At the end of this section, you should be able to A. Discuss timber producing trees, and B. Discuss felling trees. What are timber producing trees? These are the type of trees that are able to be converted into marketable sized lumber that can be used to make structures such as furniture, roofs, staircase, and so on. Generally, trees are classified as hardwood and softwood. These can be identified by the size and shape of the leaves and the cell structure. One of the ways to identify softwood trees is to examine the leaves. These will have usually fine needle-like leaves. Another way to identify hardwood trees is to examine the leaves. Hardwood trees are usually broader in leaves than softwood trees. The trees mainly used for household furniture are mahogany, cedar, and pine. Softwood trees are popular in the building industry. Felling a tree. Have you ever wondered where the wood comes from to make